Okay, cool. So, so basically, this introduction part is for the other candidates who are not aware about the database. So, this major features in the Postgres like portable, reliable, scalable. So, these are some theoretical topics. Then, general database limits in the Postgres. One second. Yeah, so general database limits in the Postgres is the maximum database size is unlimited. I think in the SQL Server there is a limitation in the terabyte, but in the PostgreSQL there is no limitation on the database size, and the table size is 32 terabyte, and the row size is 1.6 terabyte. The field size, the field, I means the particular value that we are creating in the table, so that we can have a maximum to 1 GB, and the maximum rows per table is unlimited, and the columns per table is 250 to 1600 depending on the column data type. Okay, and the maximum indexes per table is also unlimited. So we have a database size, and the indexes size per table is unlimited in that PostgreSQL database. Okay, as compared to the other databases.
Mm-hmm.
And in the common database, object names in the PostgreSQL is in the SQL Server, Oracle, some other RDBMS database. The table we call, and in the PostgreSQL we called as relation, not table. Okay, we call it table, but in the PostgreSQL terms, in the PostgreSQL documentation, you will get the, instead of table they give the relation. Okay, in the
Yeah.
server Oracle we called as row, in PostgreSQL we called as tuple. Okay, and in the
Mm-hmm.
other databases we called as column, in PostgreSQL we called as attribute.
Mm-hmm.
Data block, so in SQL Server, like in other databases, Oracle, we have a 8K, 16K data blocks. So in the we normally in the we have SQL Server databases hosted on the Windows operating system. So when we format that particular drive, data drive or STEMDB drive, so we format that with the NTFS 64K format. That is the standard, right? So
Mm-hmm.
in PostgreSQL, the whatever when we creating the data, so there is a in the when we initialize the database, then we can give the size like 8K, 16K, I mean kilobyte data
Mm-hmm.
page size. Okay, so in SQL Server we have different pages in the architecture level like SGAM page, GAM page, data page, index page. So for Postgres we don't have like those pages, so we just have the data storage block. Okay, in the page SQL Server we called as buffer, and in the PostgreSQL we called as buffer. Okay, so I'm just relating those the SQL Server, those, that's why I'm just relating those terms. One
Mm-hmm.
second, it's not, your voice is a bit low.
Yep, I can see your screen.
Okay, in SQL servers, when we do the installation, the system databases get created. So in SQL Server, we have a default instance, MS SQL Server. We can create the name instance as well. So in PostgreSQL, we called as cluster. So in SQL Server, we called as instance. In PostgreSQL, we called as cluster. Okay.
Mm-hmm.
So in cluster, we can create the multiple databases. So that is called as cluster. So cluster is a basically collection of databases. Okay,
Mm-hmm.
in SQL Server, we have the logins, okay, at the instance level. So same here, the logins and users we have at cluster level. Okay, so there are three objects which are at the cluster level in Postgres: users, databases, and table spaces. So users is basically logins. So in Postgres, we call it as users, and also there is one part roles. So there is a difference between roles and users or logins. Okay, so in server, you can set login and then roles. So login is basically the SQL Server logins or Windows authentication logins that we create in the SQL Server, and role is basically the data reader, data writer. So those are the inbuilt in the SQL Server, right? So
Mm-hmm.
in Postgres, until Postgres 15, we were not having the inbuilt roles like data reader, data writer, but in Postgres 14 and 15, we have the inbuilt role reader and writer. So in Postgres 10, 11, 12, 13, 14, so we have to create the reader writer role manually, and then we have to grant the access to the users to that particular roles. So difference between role and user is that user can log in into system, okay, but a role can't. Role is having just permissions, so we can grant those particular roles to any other logins. Okay, so in SQL Server, you can compare like the logins can do the login, but roles like data reader can't into the database. Okay, so that is kind of difference between users and roles in the Postgres. So users, then database and table spaces, these are the same level on the cluster level. Okay, and the table spaces is like the file group in the SQL Server. Basically, in SQL Server, we create the file group, primary file group, secondary
Mm-hmm.
file group on the different drives. So we can create, right? So in the same manner, so we have a default table spaces in a SQL Server. Or also, if you want to put a particular data directory on some let's say we have one database or we have a multiple databases, 10 databases. You want to put one database in a one hard disk, or you want to put statistic data for faster performance on the SSD on a different drive, then we can create the different table space, and we can put that table space or table particular table or set of tables in that particular table space. So it is the same kind of working like for file system in the SQL Server. Okay. So this table space concept is a similar in Postgres as well as in the Oracle. Okay.
Okay.
So inside the database, we have a catalog, schemas, extension. So as compared to the SQL Server, you can consider in the databases, we have a default schema called as DBO, right? So in
Mm-hmm.
Postgres, we have a default schema called as public. Okay, so inside that public, so we have a catalogs in the SQL Server, right? Inside the DBO, we can query, right, select star from sys.table. So sys, then information underscore schema. So these are the some catalog tables in the SQL Server. The same way we have a default catalogs in the Postgres as well. So so we can query those system tables in the Postgres. Extensions is basically what called for the extra or additional purposes. So for example, if you want to create the link server between the databases or link server the two servers, then in SQL Server we can directly create the link server in the server object. We can go to the server object, and then we can just create the link server. But in Postgres, creating the link server directly not possible. Okay, so if you want to access in the if let's say there are two databases, same instance. Okay, so first I will give the explanation in the SQL Server, then I'll explain on the Postgres level. So in SQL Server, if you want to access a database, there are two databases, ABC and XYZ. Okay, so if you want to access the data from the ABC to XYZ, then in SQL Server it is directly possible. In the query window, you can just give the database name, then of the object DBO dot object name, then you can directly access data from the other databases in the same instance in the SQL Server.
Mm-hmm.
So in Postgres, that is not possible. In the same instance, if you want to access database or data from the other databases which is present in the same instance, so you have to create the link server for that. Okay. If you want to access data from the another instance, for that as well, you have to create the link server. So link server we can create between Postgres to Postgres, Postgres to Microsoft SQL Server, Postgres to Oracle. So there are extensions available for that. Okay. So if you want to create a link server between Postgres to Postgres, that there is called as Postgres underscore FDW. Okay, or there is also one more extension, DB link. So using those two extensions, we can create the link server between
Okay.
the two databases or two instances. Okay, and also there is a in the SQL Server we can just create the link server in a single line using TSQL, but in a Postgres there are set of commands or set of steps that we have to follow to create the link server. First we have to create the server, then we have to create the schema, then we have to do the user mapping, then we have to import the schema. The total different architecture of the link server in the SQL Server and Postgres. Okay, so
Mm-hmm.
extensions are part of those. there are I mean whatever we are getting the PostgreSQL after the installation. So those if you want to say something anything extra, then there are a lot of extensions available in the market, in the community, as well as third party extension. So we have to
Mm-hmm.
exchange install those extension if you want to I mean need that functionality. Okay. So the one more example I can give in the Postgres, if you want to do the vacuum, if
Mm-hmm.
you do the full vacuum on the table, then it will apply exclusive lock on that table. But there are extension that is called a PG underscore repack. So that extension, if you install it, then it will do the that vacuuming or indexing. Then that there will not be an exclusive lock on that table. Okay. So
Mm-hmm.
if you want to need additional functionality, then we have to install that extension. Then
Mm-hmm.
in the schema, we can create it like in the SQL Server, we can create the table, sequences, functions, event triggers. So like store procedures and functions available in the SQL Server Oracle. So same way there are these objects we can create on the scheme inside the schema. So in the Postgres, we have a default schema called as a public. So under this public schema, we can create these objects. So we can create I mean the user schemas, or we can create the user table spaces. What one second. So this is the basic the hierarchy of the PostgreSQL cluster. Do you have any question on this?
Nope, I'm good.
Okay, perfect. Then in the Postgres, we have a different architecture called as process architecture, memory architecture, then storage architecture. So these architecture basically in SQL Server, when we install the SQL Server, the default for the database engine, there is a service automatically get created in the services.msc. So that is called as a one process. As a part of storage architecture, install the SQL Server at the storage level, default master MDF file get created, then LDF file created. If you create a secondary data file, then NDF file get created. So this MDF, NDF, LDF. So these are the storage architecture in the SQL Server. So like, and there are in the C program files, the default of MS SQL folder get created. Inside that, there are different for numbering for number are there. So there is a purpose for each folder. So like in Postgres, when we install the Postgres, so and after the installation, when we start the Postgres, some processes automatically get created in the OS level. So that is called as the process architecture. Also,
Oh.
when we start the PostgreSQL, there are some memory get allocated in the memory on the server. Okay, so in the memory there are different parts allocated. Okay, so that is called as the memory architecture. And then on the storage level, data directory got created. Inside that data directory, there are some folders, structures. So there is a significance of each files and folders in that data directory. So we are going to cover all those files and folder. What is the importance of these files, that folder? So
Mm-hmm.
these are the part of this process memory architecture. So this diagram basically covers the process architecture. Okay. So when we start the Postgres and Postgres is up and running, and when user connects to the database, okay, then that request goes to the postmaster process. So by default, Postgres runs on the 1433 port. Sorry,
Mm-hmm.
SQL Server runs on the 1433 port, and this
Mm-hmm.
Postgres runs on the 5432 port.
Okay.
Okay, and when the user connect to the database, that request goes to the postmaster process. In the postmaster process does the authentication, and if authentication is done successfully, then that postmaster process create the backend process for the Postgres process. Okay, each process authentication or each request, it create the backend process. Okay, and then backend process whatever it is doing, select, insert, update, delete, that memory query life cycle. It will go to the all the query life cycle, like in SQL Server. It is what we can do: parser, analysis, then uh, whatever is the query cycle in the SQL server, it
Mm-hmm.
to all this query life cycle, and then you will get the result. So to get those results, there are some background processes running in the PostgreSQL. So like writer, wall writer, check pointer, archiver processes, logging collector, stats collector, auto vacuum launcher. So these are the background processes or processes in the Postgres. Okay, so these are the almost 7 processes which are the mandatory processes in the Postgres, and there are optional or additional processes as well, but that we are going to cover later. So writer processes is basically which writes the data into the this data file. Okay, wall writer process is basically which writes the data into the wall file. So in SQL Server, you don't have these different processes like to write into the MDF file, we have a different process. To write into the LDF file, we don't have a different process. But in Postgres, we have a total different. If you want to write in a data file, there is a different process. If you want to write in a log file, there is a different process. Okay, so a wall file is basically you can compare LDF file or log file or transaction log file in the SQL Server. In Postgres, we called as the wall file. Wall stands for a write ahead log.
Okay.
Okay, so so we have a writer process which writes the data to the data files. We have a wall writer process which writes the data into the wall files. Then we have a check pointer process. You know the check pointer in SQL Server, Postgres, all the
Correct.
RDBMS database
Mm-hmm.
have this check pointer process. Okay, then we have archive process. Okay, so archives process is basically you can compare in the SQL Server with the recovery model. So in
Mm-hmm.
SQL Server, full recovery model, bulk recovery model, and what one is the basic no reco
Simple recovery.
simple recovery model. So in simple recovery model, our transaction logs get overridden, right? So in
Actually,
PostgreSQL,
go ahead. Yeah.
yeah, I mean, we in a simple recovery model, we cannot do the point in time recovery or because our transaction logs get not, I mean, it is not accumulated.
Oh, you mean the
After
recovery
some,
mode? Okay. Okay. Recovery, no recovery. Okay.
yeah,
I thought you're
recover,
talking about the log methods. Okay.
yeah. So the archive process basically if you want to save your transaction logs or not, whether you are like compared to the SQL Server, whether you want to keep in a simple recovery or whether you want to keep on a full recovery. So in the production, we in SQL Server database, we usually keep database in a full recovery model for this point in time recovery for the always on. If your database is an always on, then in production systems, we keep the SQL Server database in a full recovery model. Like in Postgres, we keep the archive mode on in Postgres. So keeping the archive mode on and off. So on means we are going to preserve the transaction log files. Keeping the archive mode off means we are not going to preserve the transaction log files. Okay, it will get overridden. Okay,
Yeah.
how to switch on and switch off this archive mode that we are going to cover in the lecture. Then logging collector is basically who writes the data into the log files. Log file basically is the file where all the what we can say audit and the error logs for the databases
Mhm.
get written in the log file. Okay, so that is a process. Logging processes is a logging collector basically process responsible for those. Then we have a stats collector. Stats collector is basically used to update the statistics of the databases. So you in SQL Server also we rebuild the indexes. That's then we can update the statistics of the database as well. So in PostgreSQL we have a different separate processes for stats collector. So when we do the maintenance like vacuum in the databases, so there is we can pass the parameter analyze to update the statistics of the table, update the statistics of the database level. Then we have a auto vacuum launcher process. So auto vacuum launcher is basically inbuilt process who does the what can I say maintenance part in the databases, auto maintenance part.
Mhm.
So there is a default threshold for the vacuum process. So let's say I have a table, ABC table, and if that particular table I have 100 rows, and if I change 30 rows in the table, And if I my default threshold is a 70%, let's say my table if change is 30% or 40%, then if I set my threshold to 30% or 40%, then automatic vacuum launcher automatically triggers on that table and it will perform the vacuum operation then on that table. Okay, so this is
Okay.
a default operation or default maintenance operation. I mean, inbuilt operation in the Postgres who does the maintenance on that table. Okay, so then we have this shared memory. So this the bottom part is called as utility process, and this center part is called as shared memory. So shared memory allocated in the RAM, random access memory. When
Mm-hmm.
we start the Postgres, let's say like in SQL Server, we give the max memory to the SQL Server instance, right? Let's say I have a 20 GB memory on the server. If I want to allocate maximum 15 GB to the SQL Server, okay, we can restrict the memory on the SQL Server. The same part, we can restrict the memory, how much we want to allocate to the PostgreSQL. So shared buffer is the parameter who controls that how much memory you want to allocate to the PostgreSQL. Okay, so that shared memory, we have a shared buffer, wall buffer, clock buffer, temp buffers. So these are the different, I mean, the pools or buffers available in the shared in the PostgreSQL. It is in the random access memory. Okay, so this basically shared memory is used for the caching purposes. Okay, to improve the performance of the database. So when we have a select the data, that data gets fetched from the storage to this particular memory, and if that particular data is available in the memory, then if the next query comes, then it will directly read data from the memory instead of uh, storage level. Okay, so in SQL Server we call as hard pass and soft pass, right? So that purpose for the purposes, we have this shared memory in the PostgreSQL level.
What is clock buffers?
So clock bursts are basically used for this transaction purposes, transactions
Okay.
current state. So we have running, aborted, and that what can I say? Uh, Transaction which are in the running status, which are in the aborted, which are completed. So this running status of the transaction is tracked here.
Okay.
Okay, and temp buffer is basically used for the temporary memory, which is used for the joins, hashing, sorting. I
Mhm.
So these operations are performed here in the temp buffer. Okay, so we can tune those parameters according to requirement. Like in the SQL Server for the performance tuning, we use the query hint, right? So like in the Postgres, in the performance tuning, if you want, if a particular is having the uh, sorting operation or order by, group by, or then if your queries are not working or taking a long for the execution because it is doing a lot of sorting, then you can that particular for that particular session you can increase the temp buffer, you can increase the work buffer. So these are the some I mean the buffers that we can tweak as per for the query tuning or at the system level for that particular session, particular user. So, but that is a part of performance tuning. Okay, so when all this process is done, this is the backend structure. I mean, whatever use on the storage level. So like in SQL Server, we have NDF file and MDF, LDF, NDF file. So in and the log file. So in Postgres, we have these data files, wall files, log files, and archive files. So archive files generated only when we turn on archive mode. If archive mode is turned off, then Postgres is not going to generate these archive files. Okay.
Mm-hmm.
So SQL Server, we have a single LDF file, or we can have multiple, but usually we have a single LDF file for all
Correct.
the transaction logging. But in Postgres, we have a 16 MB each file. So there are lots of file created for them. I mean, the database size is in terabyte, then it will continuously generate 16 file. So default that max limit of this transaction log file is 16 MB. If that file get filled, another file get created. If that is get filled, then another get created. So continuous lots of file get created in the busy databases. So
Mm-hmm.
these are the wall files, and if your archive mode is turned on, and then that those are get archived on the storage level. So this is basically the backend structure. This is the process structure, and this is I mean the process memory structure, and this is the process structure. So we are going to cover each this buffer and this process. What is the writer process? When this writer process kicked off? What is the checkpointer process? When checkpointer process kicked off? We are going to cover all this in detail architecture when we start the class. Just I'm giving the overview
Okay.
like how the Postgres works. All right. Do you have any questions?
No, I'm good. Yeah.
Okay, cool. I don't know if Sonal is available or already she left.
Yeah, I think it's left.
Oh,
Uh, can you send me like, like do you have the like the index kind of what we're gonna cover, you know,
uh, yes, I'll share with the, I mean, this, let me study this and then
and
I will share with you.
we can even contact on WhatsApp, right, to each other.
I don't know if this, because, they told me don't share the number. I don't know if it is allowed or not.
Okay. Okay. Sure. So yeah, just send me the entire the curriculum that you're gonna cover, like the training part, if you have it in written. If not, that's fine. I know like what you told. But yeah,
Mhm.
so what's the next step? Should I contact them?
Yes. Your name? It's the same name, Bhumi Bola.
No, no, my
Yeah.
name is Manish. That's my wife computer, so it's for me. But okay, it's Manish.
Manish.
Yeah,
Okay.
it's Manish Patel.
Okay. I'm also using my wife's laptop.
Okay. I mean, this is my laptop, but she actually has the Zoom on her name. Like, see, you you pass the name and all right. So she
Mhm.
put her name there.
Currently, you're in
Manish Patel, not Golakya.
India or
Manish,
abroad?
yeah, Patel, Patel.
Sorry,
Manish Patel.
Patel. Okay. No problem. You can contact them and just let me know. I mean, when if you can start.
Name is Sudhir, right?
Yes, Sudhir.
Okay. Uh, so yeah, so
This
like you
is
said,
my
like you
name.
already started working on AWS, but you don't have much experience there, right? You told.
I mean, I worked in the AWS, but in my previous company. So currently, I'm working in the banking domain. So, I mean, we are not currently using the AWS. That's why.
Okay. But could you learn yourself, like in all this? Like, do you have access there, or you don't have access at all in the cloud?
In AWS,
Yeah.
I mean, I can create the free tier account, and I mean, if you want basically simple, if you create the RDS instance and on all, then I can show you that part, the basic things.
Yeah. Yeah, we can do that, right? I mean, at least, or what about the Cloud Watch? Do you have access? Do we have access there, like, for the free session, like, free?
Yeah, in the AWS free tier, we also have access in the of CloudWatch as well. I can show you how to check the logs, but definitely we are not going to cover the how to create the dash, how to set the alerts because for those we need a different services for setting the alert SNS service.
Okay.
So those services are covered in the AWS free tier. Also the Aurora part because those Aurora part required a lot of resources. So not
Mm-hmm.
also covered in the free tier. That's why I was not covering this
Okay.
AWS part. So, but we can cover
Definitely.
the basic things, how to create
Okay.
ADS instance, how to check the logs and all, how
Okay.
to change the parameters, configurations.
Yeah. So yeah, I'll reach out to those people, and then we can continue. And
Okay.
you know, it would be good if you have like a 2 hour session, like like at least like 4 days instead of having like 4 hour session in a day because it's a lot of to cover. So
No, no, no. I mean, it's a one-to-one session. Definitely not going at a high speed. So when if you think that it is, I mean, it is too much, then we can stop, and then you can stop me, and then we can uh,
Mhm.
repeat those session if you don't understand any particular topic in the practical.
Okay.
So in the practical, when I'm teaching particular topic, let's say, so I'm going to teach you like how to create the Linux machine, how to I mean the how to create the virtual box, and how to create this Linux machine, how to do the installation on the on your laptop. You have to do the same process. Okay, so then
Mhm.
only we will proceed with the next topic. So you have to
Okay.
do it practically, and you have to show me like, yeah, you have done it on the your side. There is no issue. Otherwise, there is no use of training.
Oh, definitely. And also you have a media, right? Postgres I can download on my machine.
Yes,
Same
it's a
time.
freeware.